Members, those people have funny background, please mute yourself. Okay. Take accession due to gravity to be equal to 10 meters per second squared. And we are going to find the mass of the following. So part A, suppose we are given a weight of 500 newtons. What is the mass? Weight of 500 newtons. What is the mass? So, members, are we together?
Yes.
I'm seeing a new members coming here. This is who? Brian. Brian, good morning. Stongo Brian, good morning. Okay. Stongo cannot speak, I think. Okay, so the weight is 500 newtons and they're asking us to find the mass. So do you remember this? Do you remember this triangle here? Do you remember this triangle? This triangle connects to the weight, the mass, and acceleration due to gravity. So we are going to first draw this triangle and we get the formula of finding mass. Are we together? So we draw that triangle and we shall let us first draw it for once. We draw it once, we shall not draw it again. Okay, so we have weight here, we have mass here, and we have acceleration due to gravity there. In other words, weight is equal to mass times acceleration. Mass is equal to, so what's the formula for finding mass?
Mass equals to weight divided by gravity.
Weight divided by gravity, correct. So weight divided by gravity, that's the formula we are going to use. So we shall find the mass equal to, so for part A, mass is equal to the weight. What is our weight? 500 newtons divided by, what's the acceleration? 10 meters per second squared, isn't it? 10 meters per second squared. Okay, so now what is, when we divide this by this, what do we get? 50. So Newton over meters per second squared is a kilogram. So this one is kilogram because mass is measured in kilowatt, in kilograms. Okay, so I'm going to ask you another question. Are we together? Eh?
Yes.
Okay, so part B, do for me this one. If our weight equals to, if weight is equal to 1. So what is the answer there? Very fast, someone has the answer.
1,000 kilograms.
Correct, 1,000 kilograms. So we shall say mass equals to weight over acceleration due to gravity. Have you all done that?
Yes.
So 10,000 newtons divided by 10 meters per second squared, and our weight shall be equal to 1,000 kilograms. This is easy. Okay, now, members, we have a table which is here. We have a table which is here, and we have already looked at this. So we have a table which is here. So let me first, I'm going to draw that table and I'm going to put different values, and then we'll complete it. Let me see. So the question is, let me first do that table. We have mass there. We have mass in kilograms. So you are going to copy and complete that table. Are we together? Copy and complete. So this is mass in grams. This is mass kilograms. And this is weight. Newtons. Okay? Now, the first, we don't have values here, but we are going to get those values. The first value is, so we are going to first put here, let me first give you here one example. If you have 0, let's say if you have 600 grams, so 600 grams in kilograms. If you want to change 600 grams to kilograms, what do you do?
You divide.
Okay, you divide by 1000. So you get for me the answer, which is here, and also get for me the weight. Now here I'm going to put, so here there is a dash here. Here I'm going to put 850. So you get for me a dash, there's a dash there. Okay. And the last 3 I'm putting here.
It's okay.
75. So copy and complete that. Copy and complete the table above.
Yes, teacher.
Copy and complete the table above. Is it okay?
Yes.
Members, just take a snapshot of that. We are going to continue with the lesson. You send me that on WhatsApp. Are we together? Members, are we together? Complete that. Members, are we together?
Yes.
Copy that table. You are going to send for me that table on WhatsApp when it's complete. Is it okay?
Yes.
Have you finished copying? Have you finished copying?
Yes.
But this table must be in your notes. Even the working must be there in your notes for you how to get weight. Are we together?
Yes.
Okay, so this is part A, part B, and part C, like that. All right, now let us proceed to something here. So here they're asking, did you know? They are saying what? Did you do what? Did you know?
No.
You know something about weight? So we can say not. Someone. Members, if you know that your background is not good, people are talking, please mute. We are in class. Okay? So Ruth, please help us. So sorry, but Ruth help us anyway. So we are going to look at some of the things about weight. Now, the first thing they are telling you that, did you know that the weight of the body varies from place to place of the earth? And this one I should tell you if you didn't know. That on earth, we have different places. Some places are hilly, some places are mountainous, others are in what? Other places are what? Are deep, like those people in valleys. Other people are in those people in they're on highlands in a lake. There's an island on a lake. So there are other people who live even in Rift Valleys. They are down there. So the earth is not a perfect sphere. Members, are we listening?
Yes.
Yes, the earth is not a perfect sphere. So it means that the acceleration due to gravity keeps on changing from place to place. So if this is the earth, the earth is not like that, members. The earth is not a perfect sphere, circular like that. No, the earth looks like this with various mountains, different things, others so it is not a perfect what? It is not a perfect sphere, but for us, when we are drawing, we do something which is circular like this to mean that is a perfect sphere, but it is not. So other places are in valleys, other places are on mountains. So that's why the earth is not a perfect sphere. So the weight of a body keeps on changing from place to place. The weight of the body keeps on changing from place to place. If someone here is on the mountain here, someone here on the mountain, this person will experience a lower acceleration due to gravity, because we said that acceleration due to gravity keeps on increasing as you move towards the center of the what? Of the earth. So as you move towards the center of the earth, acceleration increases. Let me say acceleration due to gravity. So acceleration due to gravity increases as someone moves towards the center of the earth. As you move away from the earth, acceleration reduces. Acceleration due to gravity reduces. So as the person moves away from the center of the earth, acceleration due to gravity reduces. But when the person is moving towards the center of the earth, acceleration increases. So it means that people who are here next to the center of near to the center of the earth, these people who are here in a valley here, for them, their acceleration due to gravity is very high compared to the people who are on the mountain. Are we together?
Yes.
Yeah.
Yes.
So we have said that acceleration due to gravity is 10 meters per second squared. It is true because we have rounded off, but it is 9.81. And that is also an approximate value. That is 9.81. But you should know that acceleration due to gravity will keep on changing from place to place. It continues to keep to change from place to place. But you'll find that around the earth, it is 9.81. But because of the earth, it has different, it's not a perfect sphere. So it means that different places, they slightly, one may be 9.82, another 9.84, something like that. Very small differences. And those small differences also cause a change in weight. Because we know that now weight is measured by, we say that weight is measured by mass times acceleration due to gravity. So if this acceleration due to gravity changes, if this acceleration due to gravity changes, so it means that also the weight is going to change. It's going to change. So the weight of the person who's here is a different weight for the person who's here. The weight keeps on changing because the acceleration due to gravity varies from place to place. So let us note that one down. But before we note it down, let me first show you something, and I show you what was happening to this person here. Is it this one? Jimmy is going to be here again. Okay, now I want you to watch this. This is an astronaut and is in the space shuttle. You can see that she's not seated, she's just floating in air. Actually, there's no air. Maybe there's air in the space shuttle, but you see she's just floating because there's no acceleration due to gravity there that is making her to come down. So as you go far away from the earth, the acceleration due to gravity reduces almost to zero. So that's why she's able just to float in air, just like that, because the acceleration due to gravity has reduced. So we know that space, let me show you the first image here. So that is what we call the space. This is the space what? Space, the International Spacecraft, Space Shuttle, this one. Space Station, this one. Space Station, not shuttle, International Space Station. So it is quite big, enormous, very big. And you can see this is the Earth, this one, the blue, these are like clouds, what, whitish things, and then the blue, this is the atmosphere, but this is the Earth, all this. So when this thing is moving, if you want to see it, do you want to see it, members, using your eyes?
Yes.
I know Pav wants to see it. Is one of the people who want to see this thing. But if you want to see it, then you need to go to space. or you need to go to South Africa. Those people who are in South Africa are able to see it using telescopes. So they're able to see it because it moves around there in that side of South Africa. So as it is moving, because this is space, so the acceleration due to gravity from the Earth is very small. So even the people who are inside this space station, they cannot experience the acceleration due to gravity. That's why that lady can be able to just float, not even standing anywhere. She's not seated, she's just floating within the space station. So one day, you can see that, okay? So you can get these videos on YouTube, and then you can see very many things there. So that's what we have just talked about, that acceleration due to gravity keeps on reducing. And if we are to measure the weight of this lady here in the space station, if we are to measure her weight is very small, because the acceleration due to gravity is very small. So this is water in space. You see how it behaves? It is just floating. So they're asking, how would you drink water there? Because the acceleration due to gravity is very small. So things are not... Okay, so let us go back to our lesson. I know you wanted to see this. So note, number one. The weight of the body, the weight of the what? The weight of the body, the weight of the body varies from place to place on the surface of the Earth. So on the surface of the Earth, the weight of the body keeps on changing. Okay. The reason is that since, or you can say because the Earth is not a perfect sphere. It's not a perfect sphere. So at different places, we shall experience different weight, because the acceleration due to gravity also changes from place to place. So because the Earth is not a perfect sphere, and the acceleration due to gravity changes from place. Full stop. Are we together? So this is what they are telling you, that this is because different parts of the Earth's surface are at different distances from the center of the Earth. It is also different on different planets. So also on the moon, it is different. So on the moon, we have different weight. So the other thing is that you should know, the other thing that you should note is weight is a vector quantity. Members, did you study vector quantities? Okay. Weight is a vector quantity because it has got a direction. Because it has direction and okay. Then lastly, we have talked about different things. So weight is a vector quantity. What else? What else do you have to know about weight? Is there anything you have to know about weight? We say that weight is measured using a spring bar balance, isn't it? Weight is measured using a spring balance. So those are that, maybe you can add on. Did we write that? Weight is measured using a spring balance?
No.
We wrote that. We wrote it down. It was the first thing. But if you don't have it, you can write it. Weight is measured using. Anything that you know about weight, members? Okay, so members.
Yes.
I think that is what the lesson is all about. We have looked at force of gravity, and that was our lesson for today. Are we together?
Yes.
So if you have any question, you can ask. I can show you this other video. No, not that one. That is WhatsApp. I can show you this other video that I showed you at first. And then we can end with that video if you don't have any question. But complete my table and send it on WhatsApp. Pav, do you know my number?
Yes, teacher.
Hey, you send. I'm seeing there are some new people have just come in. Michael, good morning.
Morning too.
Hey, this is
Anza Bridget.
Hey, you change your name to Anzo. You rename, please. Are we together? So, yes. Bridget, I'm going to upload this video, and then you need to log in first, and then you go to resources. Let me show you. Are you using a phone?
No, I'm using a laptop.
Okay, so if you're using a laptop, then you come here to resources, okay? After logging in, you click here to log in. Always click here to log in. And after logging in, you go to resources, then videos. So the videos are here. So you check the video will be here. If the video is not here, you come and click on these numbers which are here. You go to the next page and you see very many videos. Some of you don't watch these videos, but you can watch them over and over again. Now, let me show you the other video that I wanted to show you. The one that I showed these people first. And then we see to end our lesson today. So if someone asks, if you measure yourself 56 kilograms, that is not weight. That is wrong, but that is mass. So what you measure on the scale is mass. But now, how do you measure weight? Weight, the units are newtons. So suppose you have 1 kilogram bag of sugar. Grams and kilograms are units of mass. That's what they are saying. Are we together? So if this bag is 2 kilograms, then what would be its weight? So you don't say that the bag weighs 2 kilograms. No, the bag has a mass of 2 kilograms. But if you want to measure weight, you use a spring balance. This is a spring balance. So you hang the mass here, and this bag of sugar of 1 kilogram, it will be 10 newtons, meaning that the spring balance gives the weight in newtons. So how do you get the weight? We use the formula of force is equal to mass times acceleration. So by this acceleration, we can write it as G. And G is the acceleration due to gravity. Mass is the quantity of the body in kilograms. Now they are telling that on Earth, the acceleration due to gravity is 9.8 meters per second squared. So if you have 1 kilogram bag of sugar, to get its weight, you multiply 1 times 9.81. So if the bag of sugar has a mass of 1 kilogram, then its weight is going to be 9.8. Okay, here they are using 9.8, but for us, we shall use 10. Are we together? We shall be using 10. Now, if you take this bag of sugar to the moon, because it is very small, then its acceleration due to gravity is also small. It is 1.6 meters per second squared. So that's why you see that on the moon, people can float in space because the acceleration due to gravity is very small. Now, if we want to find the weight of this bag of sugar on the moon, then its weight is going to be 1.6 newtons compared to 10 newtons on Earth. Members, are we together?
Yes.
Yes.
So 1 kilogram of sugar on the moon weighs 1.6 newtons. Now, Jupiter is another planet in the solar system. Its acceleration due to gravity is 25 meters per second. So this one, it has the highest acceleration due to gravity. So the weight of 1 kilogram, the weight of a mass of 1 kilogram on Jupiter, it would be 25 newtons. That is quite big. Whereas on Earth, it was only 10 newtons, but on Jupiter, it is 25 newtons. So any object that is thrown away from the Earth, this force of gravity makes its speed to reduce until the object stops and then goes back to the Earth. That's what they are saying. So that acceleration is what we call the acceleration due to gravity. So members, we have less than 1 minute. If this